Hello and welcome to my channel, The Complete CSC Guide, and I am Sanskriti. In today's class, I am going to teach you about the error control in data link layer. In previous class, I have shown you what was the flow control in data link layer and each and every aspect of flow control in data link layer. Now, in today's class, we will study about the error control. As I have already told you that when the frames are flowing through the transmission channel, some frames they are lost, right? So some kind of error is generated when these frames are lost in the space. So in that particular position, when some errors are coming, so we have to control that error so that the perfect message is received by the receiver. So there are so many techniques. Okay, so in error control there will be two kinds of things. First, the error detection and correction. First, you will detect the error, what kind of error have been occurred, and the error correction. Then you have to correct the error, right? So two kinds of thing will be happening. Now, today we will see about the error control. It will have some other portions also. Day by day, we will progress towards the error detection and correction. Okay, so first of all, what is error control? We have to know about the error control. First step to control your error is what is the error, what kind of error. So we have seen there in the previous video that what was the errors, what kind of errors were happening there, right? So when the frames were flowing, some errors were generating, that some frames were lost and some error were happening. Now what kind of thing is error control? When this transmission some error is happening, we have to control that particular error, those particular errors. There can be two kinds of error. One is the single bit error and second is burst error, right? So two kinds of errors are there. So step by step, let's see. Error control. Data can be corrupted during transmission. Data is lost, it is lost, again the frame is sent. That we have seen in the stop and wait protocol, that what was happening, data was lost, again it was sent, retransmission was done. But if some corruption happens in this kind of error flow, then the error transmission, the frames are being transmitted, but in this data transmission, within this data transmission, some kind of corrupted data is there. That is, some data can be corrupted during the transmission. Maybe they are sent to the receiver. If they are lost, they are retransmitted. But if these errors are corrupted and then received by the receiver, then how you will detect that the error is, the particular frame is or the particular data is corrupted? Then you have to search the error and you have to detect it and correct it, right? To give the correct message to the receiver. Now, for reliable communication, errors must be detected and corrected. So here, errors have to be detected, then error have to be corrected. Now, this is the technique of error detection, retransmission. That is detection and retransmission. That's as I was telling you, that lost frames are retransmitted, and here, if some corrupted frames are there, that we have to detect the error and correct it. That is error detection and then retransmission, right? So that the correct, the main purpose is what? Here the main purpose is our whatever thing we are sending the data to our receiver, that should be the correct one. The correct message should be sent, and we have to see nothing else is lost within this transmission, or nothing is corrupted data is not sent to the receiver. So we have to keep that particular thing in mind. Now, what are the types of error? First is single bit error, that is one bit error. If one bit error is there present in your particular frame or your particular data, that is called single bit error. Or burst error. Burst error means there can be more than one error, right? So there can be multiple errors. So burst error is about multiple error and single bit error is about your single data error. Now, single bit error, we have to see what is single bit error. So one bit of a given data unit such as byte, It can be a byte, it can be a character, it can be a data unit or packet is changed from 1 to 0 or 0 to 1. Now, what is the data? What kind of data? What do you think about what kind of data is going to be transmitted? We are not sending some words, are we? We are not sending some words, we are not sending some sentences. These data, what we are transmitting is in the form of these 2, 0 and 1. So, this is digitally we are sending this data, right? So, it can be either 0 or it can be either 1, binary. Now, here what is happening? The corruption can be that the corrupted data can be either 0 to 1 is going to be 0 or 0 is going to be 1. This error can happen. Exactly this is the error what is happening in Rust error also. 0 can be 1, 1 can be 0. So this is the error what is happening each and every place. In place of 0, 1 is coming. This is the error. This is the corrupted data. Again in case of 1, the 0 is coming. That is the corrupted data. So this much is happening each and every place. This is what is called as your corrupted data. Now here it can be a byte, a character or a data unit or a packet. This is what is the error can be. But it should be a single bit error. If it is a single bit error, then it's called single bit error. That is only 1 bit error can be there. That is your single bit. Now, here you can see the whole figure. What is there? This is my message which the sender has sent this message and the receiver had received this message. Now, here what you can see, the whole message is same. But here a particular bit that is here, it was 0. But when it had received, it is 1. This particular bit is corrupted when it had been transmitted, right? Sender had sent this particular message, but the receiver had received this message. Now, what is the difference? This particular bit is changed. This is 0. When the sender was sending, it was 0. And the receiver, when it received, it was 1. It is 1. So, this much had happened. This particular bit is corrupted. So, it is a single bit error since single bit corruption have been done. Right? So, this much error is known as single bit error. If in any messages or if any frame, whatever thing you are sending, if 1 bit error, you are getting 1 bit error, that is your single bit error. So, this thing will happen, that 0 will be 1 or 1 will be 0. This all thing, this can be happen, okay. So, this is the main thing what happens in each and every place about your error. But here only we can see a single bit is corrupted. So, it is a single bit error. Done. Now, Rust error. Now, what is Rust error? That is 2 or more bits in the data unit have changed from 1 to 0 or from 0 to 1. Same thing. 0 to 1 and 1 to 0. Same thing is happening each and every place because 2 bits are only there, 1 and 0, nothing else. So, error can be what? 0 can be 1, 1 can be 0, nothing else. This much is there. But in Rust error, 2 or more than 2 bits can be corrupted. That you can see here the message which is sent and which is received. So, what you can see, there are 5 bits. Here, these much bits, these 5 bits. Okay. So, what was the bit? 0, 0, 1, 0, 0. This was sent by the sender. Now, when the receiver had received, he had received what? 1, 1, 1, 0, 1. So, this is the corrupted bit. So, we can see here that's this much, whatever we have sent. So, more than 1 bit is corrupted. So, it is a Rust error. It is known as Rust error, right? 2 or more than 2. So, that is more than 1. More than 1 error, if you are getting, that is a Rust error. That's all. So, here you can see that this much. So, bits corrupted by Rust error. Length of the Rust, that is error, 5 bits are being corrupted. What is happening here? You can see that in this message, this bit is changed and this is changed. These two are not changed. But if in the same thing, if in the line whole thing, if this much bits are changed, then you can easily understand that the whole thing will be, the whole message will be changed. Since this thing is changed, okay, if this particular matter is changed, the whole thing, this is the 5 bits. So, if these things are changed, then obviously in between, if these bits are not changed, then also the whole message will be changed. So the whole thing is taken as corrupted, right? So this much thing is corrupted data, and it is known as burst error since it is having two or more than two errors: single error, single bit error, and this is burst error. Now what is the technique? Now since you know about the error now, single bit and burst error, now when you have known about the error, now you have to know what are the detection techniques. If you know that yes, whatever work I am doing, there is a error in my, you have done a programming and you know yes, some error is there. Now you have to know what kind of errors are there. First of all, you are doing a simple C programming. Now you have to, first of all, you have to know that what kinds of error are there. After that, when you are running the program or you are compiling the program, you will get some error, right? You are not getting the error, the program will run. But if you are getting some error, then what you have to do, you have to see that what are the different kinds of error, you have to know about them. Now you know about what kinds of error are there here in data link layer. Now second is, if you are getting the error, now you have to detect the errors, where my errors are, where I have got the errors, right? Then when you have detected the errors, you have to correct those errors. You are getting a perfect program. Here also same thing, we have known about what are the errors. Now the error detection techniques or method, how you can detect the errors, that is here, right? So basic idea, add additional bit to a frame that can be used to determine if errors have been introduced. What we do here, to detect the error, we add an additional bit to the data, that is an additional bit to a frame that can be used to determine if error have been introduced or not. A particular bit is been introduced here. This is the technique of detecting the errors. Now what are the different techniques? Now there are some techniques, the method will be same, to insert a particular bit, but the techniques are different. Three techniques are there. First is parity check, that is parity. What is the parity of your particular checking of your error? Second is cyclic redundancy check, that is your CRC. Okay, CRC checking is also a method of detecting the error. And third one is checksum. So these are the three kinds of methods or techniques by which you can detect the error in your frames, sent frames, right? So now parity check. What is that? One bit called parity bit is added to every data unit so that the total number of errors is the data unit becomes even or odd. That is, a particular bit is added to your data. Why? That will show that whether I was having, if I was having 3 zeros and this was my message. So here I know that 1, 2, 3, 4 and 4 zeros are there. That is my even, parity is even number of zeros I have and odd number of 1 I have. Now adding a single bit will show that whether your parity changes or not. That is, if I am just showing you the simple concept, right? Then we will study what is happening here. Simple concept is, this is my message and this have even number of zeros and odd number of 1. If I will add a single bit with it, suppose I am adding a 1, right? Then what you will see, when you will check, what you will see there, that the number of zeros are same, even, but the number of 1 had changed. That is, it's not even now. It is now, it was odd, but it's not odd now. It is now even. So some kind of error had happened in my bits. Again, if a 0 is added, then you will come to know that the number of bits in the particular, that is it's even or odd, that had changed. So this particular bit will show that whether an error had occurred or not. Now let's see here what is happening. So your one bit, this particular bit is called the parity bit. Okay, now so total number of whatever is in the data unit becomes even or odd. Source that transmits data via a link, that is transmitting the data, that is your sender, and bits are checked and verified at the destination. Source, that is your sender, is sending the data, right? sending the data via the link and bits are checked and verified at the destination, at the receiver. The bits are checked, right? At the receiver it is checked. So what is there? Data is accurate if number of bits odd or even matches the number transmitted from the source, that I have told you. That if it matches with the number of bits that is transmitted, the odd or even, if it is matching with that one, when I have transmitted the data at that time, it was odd or even, if it is matching with the data which I have received, then your data is not corrupted. But if it is not matching, then your data is corrupted. This is the basic idea behind this parity check, right? So this parity bit is the main, doing as the main work, right? It's doing the main work in finding or detecting the error. Now, most common technique and least complex method. It's not so much complex. Now, let's see what is happening. Even parity means maintain even number of ones, right? And odd parity means maintain odd number of ones. Now, what is happening in parity check? What is the difference? I have told you about when it is 0, 0, 0 and 1, 0. So, this is my particular message. Okay, or let's take it like this, 1, 1, 0, 1. So, this is my particular message. Now, if I will add a parity bit, that is 1, right? I am sending the message is received. Now, what will happen? This number of ones. So, here even parity, maintain even number of ones, that is 1, 2, 3, 4. So, if I will write that the number of parity bits that was even when I was sending the bits. So, what I will do? I will add one parity, that is 1. So, my parity that had even number of ones. Now, what it happened? It had changed. Now, it is odd. Which parity bit I have added? If I have added a 0, 1, 1, 1, 0, 1, 1. Now, this is the message. And now, what is happening? If this has changed, right? So, 0, if 1, 0, 1, 1, now some 0 is coming. Now, you can see the parity which have here when I was one was added, the parity was changing. It was going to be even. But here, the parity is still odd. That means no error had occurred. But if the thing is changing, whatever my parity was before sending the message, that is here, one bit called parity is added to every data so that the total number of ones in the data unit becomes even or odd. So, we have to see that particular parity is changed or not. When I am adding the parity bit, I have to see that the number of ones that is changing or not. If it was even when I have sent the data, if still it's even in number, then it's okay. My data is not corrupted. But if it is changing, right, then my data is corrupted. In this case, what is happening? Here you can see we are adding a particular bit, right? So here I am adding a particular bit, here I am adding a particular bit. Now, when the message had been received, if here one extra 1 is there, the parity is becoming, here what is there? Here 3 were there, that means it was odd. But now when 1 we are getting here 1, 1, then it is coming as even parity. So, the message is corrupted. But if here 0 is there, that means no, again same thing, odd, 3. That means no change have occurred. That means no change means same odd ones are there. That means no any kind of your corruption had happened in your message. So, this is the basic thing about your parity check. The one bit, it will show you whether your particular thing is corrupted or not. So, here the main thing is about your parity bit. That particular one bit is known as the parity bit, and that's why it's known as the parity check. So, it's added to every. Now, source that transmits data via here, it is checked in the receiver portion, right? This one is checked in the receiver, that is your destination. Data is accurate if number of bits, odd or even, matches the number of transmitted from the source. Most common technique and complex. So, this is the thing, basic thing is happening here. So, 1011 when the parity was 1, and again here with the whatever thing is coming, that is 0. So, you have to see that the number of ones what we have sent if that is even, the receiver when it will receive, that should be even. If it is even number of ones, then yes, no corruption have happened. But if it is odd, then you will know that yes, I have detected a error is there, and our particular message is corrupted, right? Now here, cyclic redundancy check. It is also it's also a technique of detecting the error, and it's the second technique. What is happening here? Here a cyclic code is generated, right? So encodes messages by adding a fixed length check value. Here parity bit was added. Here some check value is added to the message, right? So encodes message by adding a fixed length of check value. Encoding means whatever message you are sending, you are translating the message, you are changing the message to another encoded form, which will be sent to the receiver. The receiver will decode it, and it come to know that whether some corruption is present in the message or not. So we are encoding the message by what? By adding a fixed length check value, right? That value will be used for checking or detecting the error. Now, CRCs are simple to implement, easy to analyze mathematically. These CRCs are analyzed mathematically, right? So CRC check, you will see sums in your books also. Many sums are there where you will see how the detection is done. Some examples are there also. Now here we will see some examples. Now also, I'm good at detecting common errors caused in transmission channels. So obviously, since it's a error detecting method, it will see some common errors only. So in parity check, we were checking some errors through some parity bit. Here the encoding will be done by some fixed length check value. What is happening here? Now CRC, how we are going through these steps. First, original message data word, that is MX, consisting of K bits, and divisor as CX consist of N plus 1 bits. So here the original data message is MX. This one is MX, right? This is your data word or your data message. Now next is consisting of K bits. It is consisting of the number of bits will be K. Okay, the number of bits here will be K, and then divisor as CX consists of N plus 1 bits. Here CX is the divisor, and it will consist of N plus 1 bits, this CX. Now original message, which is MX, which is my original message, what I have to do is appended by N bits of zeros. There we will append this particular message with N bits of zeros, right? Now zero extended message, when I have added these zeros to my message, then I will have some new message, right? This particular new message, MX is my message. Now n bits of zeros I have added to this MX. Now I am getting a new message, that is my TX. This is my new message, that is TX, right? Now, so this is the zero extended message, means extending the message with some bits of zeros, that is my zero extended message, and that is TX. Now what will we do? We will divide this TX by CX and find the remainder. CX was what? Our divisor. Now we will divide this thing by CX, that is my divisor. Which one? Not the main message. After appending the zeros, the message which I am getting, that particular message I will divide with my divisor, that is CX. Now we will find the remainder. What is the remainder there? When I will divide it, what will be the remainder? Now next, division operation is performed by XOR operation. In digital, you have studied about the XOR operation. So division will be done by this XOR operation. Okay. Now the resultant remainder is appended to original message MX and CRC and sent by the sender as code word. Done. Now let's see what is happening here. Okay, it is not so much typical, it is simple, but you have to keep the whole process in mind, then only you can understand easily. Okay, now let's see what is happening. So first of all, what I am getting, I am having a message, that is my MX, right? This is my message, that is MX. Now how many bits? It consists of k bits. It is having k bits. Okay. Now I have a divisor cx. Cx is my divisor, right? Now what is happening? I am appending some zeros with my mx plus some zeros. That is, I am appending how many n bits of zeros, right? Now I am getting a new message, that is my tx. This is my new message, right? Now what I have to do? I have to divide this tx by cx. Okay? Now I will get a particular remainder. Then the remainder which I will get now, okay, whatever remainder I will get after dividing, I have to, the resultant remainder is appended to original message. Now mx plus this remainder, whatever remainder I have received, this will be my CRC and it will be sent by the sender as the code word. Done? So this is the thing which is happening. First of all, you are having a message mx and a divisor cx. What you have to do? Append n bits of zeros to the original message. Divide, then this whole thing is your tx, right? Now you are dividing this tx with your cx, that is your divisor. New message with the divisor. You are getting a remainder. Now you have to make the keyword, that is the CRC, you have to append the particular remainder whatever you have achieved with the original message mx, and you will have the whole code word. This is the thing which is encoded version of your main message, right? So this is what is here. It was telling you about some check value, fixed length check value. This is the check value. Now you can see here, this is the sender and this is the receiver. What is happening here? The data word, both have the data word received. Here the generator is there. What is the generator? This particular thing which is done, this division on this, getting this particular the code word, this thing is done in this generator. This will generate a particular code word. That code word will be sent to the receiver. What the receiver will do? It will receive the code word and it will check the code word, that it will decrypt or it will decode the message and see whether the message which was sent, it was correct or not, and it will have the data word. Here checker, what it will do? It will decode the message and it will get the original code word. So basically this data word generated, code word is sent, checked, that is decrypted, and the data word is received, right? Now in polynomials, what is happening? Patterns of zeros and ones can be represented as a polynomial with coefficient of 0 and 1. Okay, here the power of each term shows the position of the bit and the coefficient shows the value of the bit. This is what is happening here. So in case of polynomial, how you will see, but the main thing here, what is happening, I hope you have understood that this data word is my message. This is my mx, this is my message, whole message, right? Now here in generator, what I am receiving lastly, mx plus, what is this generator is giving me? The code word mx plus my remainder, right? Here it is sending the mx plus my remainder to here. The checker is getting, again it is just decoding and getting the mx. It is getting the main message. This is what is happening in the receiver side. So this is the proper way how this CRC is made, right? And it is appended with the message and the whole thing is done as a code word and it is sent to the receiver. So this is the thing which is happening in case of your CRC check, that is your cyclic redundancy check. Done? Now in polynomial, what is happening? Here in polynomial, patterns of zeros and ones are represented as a polynomial with coefficient of 0 and 1. Now the power of each term shows the position of the bit, the coefficient shows the values of the bit. Here you can see what is happening here. Okay, let's see. I will show you. Here you can see that what is happening here, that is A6, A5, A4, A3, A2, A1, A0, right? Now, this is my data, this is my particular data, 1, 0, 0, 0, 0, 1, 1. So, when I will change this as a polynomial, then what I have to do for this one, this is my power. A6 means to the power of 6. So, what will it be? 1x to the power of 6 plus 0x to the power of 5 plus 0x to the power of 4 plus 0x to the power of 3 plus 0x to the power of 2 plus 1x to the power of 1 plus 1x to the power of 0. So, this is the binary pattern. Okay. This one is your binary pattern and this one is your polynomial pattern, right? So, this kind of thing you have to do to translate the binary pattern to your polynomial pattern. Now, this is the extended version which we have written. But this way you are not going to write, right? How you will write this? So, this is my particular message. 1, 0, 0, 0, 0, 1, 1. This is my binary pattern. And what will be the polynomial version of my message when I have this particular data? That will be x to the power of 6 plus x plus 1. From this particular thing, you will receive this x to the power of 6, 0, 0, 0, 0, nothing, x to the power of 1 and plus 1. X to the power of 0, that is 1. So, 1, since you have here 1, so 1. So, this is the thing, the whole message, the short form of the message which you will get when you will do this calculation or do this transformation from binary to polynomial, right? Now, next is internet checksum. So, this is your CRC. Internet checksum calculated value that is used to determine the integrity of data. Here also we are determining the integrity of data with the help of some checksum. Now, calculate traditional checksum. What is happening here? So, in the sender side and the receiver side, some functions are going on. What is happening? Sender side message is divided into a 16-bit word. A 16-bit word, we will break the message into 16-bit words, right? Whatever your message is, you just break the message into 16-bit words. Now, value of checksum word is initially set as 0. First of all, your checksum will be initially set as 0, okay? Then, all words including the checksum are added using 1's complement addition. Now, all words, they are including the checksum, whatever checksum. The checksum is initially it is taken as your 0. Then all words including the checksum are added using 1's complement. I hope you know what is 1's complement. So, it will be added using the 1's complement. Now, some complement made a checksum. Now, this sum which is after getting this complement addition, then it will make a particular checksum, right? The checksum is sent with the data. Now, when you are getting this, now you are doing the sum of this complement and whatever thing you are getting, you will append this. The checksum is sent with the data. The data is sent to the receiver with the particular checksum. Now, the receiver had received the particular message. What it will do? Message and checksum are received. It is getting the message and it is getting the checksum also. Now, message is divided into 16-bit word. Again, it will divide. All words are added using 1's complement addition. Again, same thing. It is also adding as 1's complement. Sum complemented and becomes new sum, new checksum. Now, these sums are complemented and it is becoming a new checksum. Now, checksum is equals to 0. First of all, same thing. Message is accepted. Now, the message is accepted. If the checksum is 1, then the message is rejected. So, here our checksum was initially 0. Then, we were doing the 1's complement addition. We were making the checksum, sending the data with the checksum. Receiver is receiving both the data and the checksum. Then, it will again do the 1's complement. It will get a new checksum. Now, this new checksum, if it is 0, right? If it is 0, then the whole message is accepted, there is no corruption. But if it is 1, then the message have some corruption and the message is rejected. So this is the particular thing which is happening in case of your checksum. So this, by this figure you can see, this is the figure how the checksum is generated. Here it's the sender and this is the receiver side. Same thing, whatever is written here, whatever is going on, this is the simple process. But whatever things are done, that is shown in a figure way. In the case of a figure, how we will show it. So this is the process. This is the message, that is, this is the 16-bit message. We are breaking the message into 16-bit word. Then we will generate a checksum which we will add. So message plus checksum. So this is the process. By 1's complement you are getting the particular checksum. So this checksum is generated here, and this is with the message. This was my message, and with this is the checksum which is added and sent to the receiver. It is sent to the particular receiver. Then receiver, it have the message plus checksum. It will be checked here. Here the checker, it is checking the particular checksum it is getting, right? Then if it is yes, if 0 it will be yes, if 1 then it will be rejected. Means if 0 it will be taken as the message, okay, and if 1 then that will be discarded, that is it will be rejected. So this is the process by which this internet checksum is done. That is your checksum process is done. In each and every process you can see the main purpose is to detect the error. Here we are not correcting the error. Here we are just seeing whether my message has some error or not. In the parity check we have seen that again that particular parity bit was sent to see whether some errors are there or not. The ones whether they were even or odd. In the message received, same thing, if it matches with that then it's okay, it is having no error. If it doesn't matches then it had error. But how to correct that error, that is not shown in this process. These are only for detecting the error. Again in CRC, there also you are getting the particular message, but here also whether some kind of error is there or not, we are checking with the help of CRC. With the help of checksum also you are checking whether your message have some error or not. Now how the error will be corrected, that will be another portion. But till in today's class I have shown you that how the errors are detected in your data link layer. This is the error control process, whole process, detection plus correction. So this much is about your detection of error. Whatever errors are there when the data is transmitted, if some corrupted bits are there, maybe a single bit or maybe burst error, that is maybe multiple bits of errors, you have to first of all detect those errors and then correct those errors. So this is the process of detecting the error. This much is there in your error detection portion, the checksum, the parity bit and your CRC check. Now how you have to correct it, we will see some another day. But till then, if you have any kind of doubt in this particular portion, you can ask me in my comment section. I will show you, or I will tell you about your queries. I will try to solve your queries. Or if you have any kind of suggestions which you want to give me, or any topic which you want me to explain to you, you can tell me that also in my comment section. If you like my channel, then please like and subscribe my channel and share it to your friends. And till then, take care and goodbye.